Hi everyone, welcome to Research Simplified. I'm Professor Phoebe. I have a master's in molecular biosciences and a doctorate in public health, specializing in research methodologies. I'm here to share with you bite-sized insights, fun facts, and some tips and tricks to help you make sense of, what research is. So let's dive right in. Today, we're going to dive into the world of biostatistics, what it is, why it matters in public health, and why you shouldn't let those numbers and equations scare you off. Then I'll wrap it up with the top 5 most popularly used statistical tests in health research. If you've ever been intimidated by the words t-test or confidence intervals, you're not alone. So let's break it down together and discover how biostatistics touch our lives every single day. Well, first off, what is biostatistics? Simply put, biostatistics is the science of applying statistics to biology, medicine, social sciences, and public health. Think of it as a way to make sense of all of the data that shows up in health research, from how well a treatment works to when a disease will strike next. So whenever you hear a new drug reduces the risk of illness by 30%, or obesity rates are rising, that's biostatistics at work. Now, why is biostatistics important when it comes to health research? Well, it does many things. And this includes making sure that solid studies like clinical trials produce reliable, trustworthy results. Analyzing complex health data to see what works and what didn't work, from new drugs to health policies that affect the entire community. Spot patterns in big pools of data to see where the disease might strike next and which populations are most vulnerable. Without good biostatistics, health research would be just guessing in the dark. It lets researchers and other stakeholders take massive amounts of data and turn it into clear, actionable items that are evidence-based. So a common concern that I often hear from folks is that biostatistics is just made up, or that statistics are there to twist the truth. I will admit that numbers can be represented. In fact, there's even a book called How to Lie with Statistics, written by Darrell Huff, that shows how statistics can be used to lie and manipulate people. The good news is, at its core, biostatistics is a rigorous discipline with strict standards for collecting and analyzing data, especially when it comes to health research, because it's going to impact human beings. Biostatisticians are trained to design a quantitative analysis so that it reduces bias and provides clear results. Whenever statistics are misused or misrepresented or used out of context, it's a problem with the user and not the tool itself. And that's why peer review and careful methodology is so important when it comes to health research. If done correctly, biostatistics can be the backbone of reliable, evidence-based medicine and helps protect people from misinformation. Now, here's an analogy that I love to use. Biostatistics is like a toolbox. Imagine you are fixing something at home. You wouldn't use a saw to hammer in a nail, right? And that's the same thing when it comes to biostatistics. You need the right statistical tool for the job that you are doing. This is where biostatisticians shine. They are trained to know which tool to use for what. Using the wrong tool can mess up the results, just like how using the wrong tools can mess up your entire home project or cause someone to get hurt. Okay, now I want to talk about something that is pretty relevant for prospective and current students. Let's talk about something that people often experience but rarely confess: math and statistics anxiety. The moment numbers and equations come up, folks' brains shut down and they just want to run away. I see it happen in so many of my students. I even see it happening in my own kids. But here's an encouraging fact. While research shows that math and statistics anxiety are real, they are very manageable. And also, sometimes a little anxiety could cause someone to prepare more. Math and stats anxiety can come from bad school experiences or this notion that you have to be a naturally born math genius in order to get it. But when it comes to biostatistics, you are not reinventing calculus. In health research, it often relies on understanding patterns, concepts, and just figuring out which tools are the right tools to use. Not so much memorizing long formulas. With practice, support, and real-life examples, almost anyone can get the basics needed for health research. All right, you've made it to the end, and now for my top 5 most popular statistical tests often used in health research. Coming in at number 5 is logistical regression. Logistical regression is commonly used as a predictive model, meaning you're trying to figure out what's going to happen. With logistical regression, you're trying to figure out the likelihood of a yes or no response. So in other words, if you factor a bunch of things together, would the answer be yes or no? Does that make sense? Okay, so here's a silly example. Let's say you're trying to figure out whether age, race, and geographical location will determine whether or not somebody will buy a chocolate ice cream by the end of the week. Coming in at number 4 is linear regression. With linear regression, you're exploring the relationship between two continuous variables. Now, I'm not going to go into depth about the different types of variables out there. I'll make a different video on that. With linear regression, think about the graphs that you see often with the line going up and some dots on the side. This is something that we probably learned in middle school or high school. You know, y equals mx plus b. So anyways, here's an example for linear regression. Let's say you're trying to see if the number of hours studying for an exam is related to the exam score. I would like to think that it does, but I do know a few lucky people who are exceptions to this rule. Number 3 is ANOVA, which stands for analysis of variance. And ANOVA is basically when you compare the averages of 3 different groups, not 2, 3. So an example would be checking to see if there's a difference in approval rating among the 3 K-pop demon hunters. Number 2 is the chi-square test. A chi-square test tells you whether or not 2 categorical variables are associated or related to each other. So an example would be whether or not loving chocolate ice cream is associated with the gender type. And coming in at number 1 is our handy dandy t-test. With the t-test, it's meant to compare the averages of just 2 groups. Now, there are different types of t-tests, which again, I'm not going to go into today. I'll make a separate video on that. I guess with the t-test, just think about ANOVA, but instead of 3 groups, it's only 2. And with an ANOVA, think of a t-test, but instead of 2 groups, it's 3. Yeah. So an example would be comparing the miles somebody can run before and after a running clinic. These tests are used across countless studies to figure out what really matters. And just like the toolbox metaphor, each test has its perfect fit, and using the right one for your data can make a world of a difference. So next time you're faced with statistics, whether it be in class or seeing it on the news, just remember, biostatistics is simply a tool to help us make more accurate decisions on what to do next when it comes to health research. And just like any carpenter and their toolbox, the key is to learn what each tool does, practice using it in different scenarios, and almost everyone can get familiar and confident enough with biostatistics. Just be patient, find a good mentor, and go step by step with the entire process. Embrace the numbers. They're here to help you, not scare you away. Don't forget to like and hit subscribe. I'll be hopefully uploading videos every single Wednesday. At least that's what I keep telling myself. I'm Professor Phoebe. Thanks for watching. Keep asking questions and see you next time. Bye.